In this video, I'm going to go over a question that I got on the graphical STEM medley. I only got it on H, so I thought I'd just go over the parts on the last part, E through I. So they gave you this function H, and they wanted you to find H of -2. So you want to plug -2 in. And what we can figure out is when we integrate from -2 to -2, there's no area, so that's 0. So 2 plus 0 is 2. Now when we do H prime, we are going to go through derivative of 2 is 0. We're going to use the second fundamental theorem. Since the bottom limits a number and the top's just an x, we're going to replace the t with an x. So the derivative of h is f of x minus 1. So h prime of -2 is f of -2 minus 1. So we can get that value for f, and that was on the graph that was given. That's 0. And then subtract 1, so we get -1. Now to find h double prime of -2, we now want to look at the derivative, and where did I do that work? I think over here on the side. Okay, so h double prime is going to be f prime. So h double prime of -2 is f prime of -2, which is the slope of the function when x is -2. So I had to find the slope of that line segment, which was 2. Okay, the next part was f. So h of 0, similarly, I'm going to go and I'm going to put in a 0 everywhere I see an x. And when I do that, I'll get 2 plus the integral from -2 to 0 of f of t dt, and then I'm going to separate it, minus the integral from -2 to 0 of 1 dt. So -2 to 0 of the function, I'm going to go and find the area of the triangle, which was 1/2 2 times 2. And then this means if I have y equal 1 from -2 to 0, it's a rectangle of 2 times 1. Or you could just integrate 1 and get t and then use the fundamental theorem. And then when you sum that up, you'll get 2. So that was h of 0. H of -5, I did down here, I probably should have done this on another piece of paper, but I did 2. And then when I put in -5, I know that I'm going to have to switch the limits, so I did that right away. Minus the integral from -5 to 2 of f of t dt, minus and a minus gives me plus the integral from -5 to -2 dt. So those limits had to be switched, which we would then have to multiply by a negative. And then I could go through and find the area under the curve from -5 to -2. So here was -5 to -2. And then I have 2 plus that area, which is 1/2 1 times 2 plus 3. And then if I add that all together, I'll get 6. Okay? Part G is the equation of the line tangent at x is -2. So we need to find h prime of -2, which we did already in part E. And then we have to find h of -2, which we already did in part E. And then we can just write the tangent line. H was the question I got. So in what open interval is the function h of x increasing and concave up? Now, I liked what they did on their solution that I believe I posted because they used different colors. And they said h prime of x, when it's positive, is where h of x is increasing. So h prime of x is greater than 0, where f of x minus 1 is greater than 0, or the function's greater than 1. So you could go to the function graph, and everywhere where it's greater than 1, we could color those parts in. Then to find out where it's concave up, we know the second derivative has to be positive. So that's going to happen, we're using that second fundamental theorem, where f prime is greater than 0. So that means where the function itself is increasing. So now if I go to the graph, and I'm going to go where it's increasing. Let me erase this yellow if I can. Okay, In yellow, I'm going to put where the graph is increasing. I want the parts that would overlap. So the -3/2 to -1 part, where it's yellow and it's in ink, and then 5/2 to 3. Okay, so that's where the graph is increasing and more y is greater than 1. Then the last part was to evaluate. Now this is really important because sometimes now we expect L'Hopital's rule to always work. Always, always, always do direct substitution. So when you do that, k of 1 is going to be, where did they give us k? Okay, they gave us that in the middle example. And we already found out in part B what that was. So it was -pi/4. Arctangent of 1 means the angle whose tangent is 1. I mean, if you had to use your calculator for that, I suppose you're allowed to use your calculator. You just have to know that the -pi/4 plus the decimal equivalent of pi/4 are the same. And then on the denominator, 2 minus h of -2, we found out somewhere. Where did we find that out? In part E. So we get 0/0. So L'Hopital's rule does work. Now I've seen other ones where it doesn't, because when you do direct substitution, you actually get an answer. So just be careful to always check to make sure it's 0/0 or infinity/infinity to apply L'Hopital's rule. The other two biggies is to make sure you put those two things, 0/0 and that you're applying L'Hopital's rule. That could be worth 2 points. Okay, so I applied L'Hopital's rule by taking the derivative of the numerator over the derivative of the denominator. This kind of went off the screen a little bit. So I have to figure out k prime of 1 plus, when I put in 1, I'll get a half on the top, over 2 minus h prime of -2. So again, k prime of 1 we found out in part B. So a lot of times they go back and use this. So if you make a mistake and you had the wrong value for k prime of 1, I'm going to assume that if you use it correctly in this part, you'll get that point. So they're not going to keep double docking you off points. Same thing with the denominator, h prime of -2 you found in part E. So if you found it out wrong in part E, you'd miss it in part E, but then you'd get it correct using the wrong answer in this part. And we'll get -1/6.